Welcome to the SNMP Southbound plugin presentation. We have mentioned earlier that thanks to translated Yang models, we can communicate with any type of SNMP-compatible network elements. To be able to do that, we need a way to upload our models to SSB. For this purpose, there is the Yang Model Upload service provided by SSB. The upload service is accessed through RPC calls, and thanks to this also through RESTconf. The requirements for models upload are similar to those required by the SMI2 Yang converter, command line tool, or Maven plugin. Now we will demonstrate the model upload with RPC calls using RESTconf. First, we need to construct the request body, which contains MIB files, including their names and corresponding revisions, and OFC MIB file body. Then we mark which ones are primary, and after this, we can post the REST request, which initiates translation and uploading of the models to SSB's model store. We have already prepared a REST request, so we can post it and see what happens. We can see that the request was successful, which is indicated by the returned HTTP code 200. OK. If some models are missing or they are corrupted, the REST call fails and returns with an error message. Let's see what happens when the request contains a corrupted MIB file. We have already prepared another request containing a corrupted MIB file. Let's post it and see what happens. As you can see, the request failed. This feedback is important for the user so he can react to a wrongly configured request or corrupted models. One important piece of information is that models need to be uploaded only on one cluster node if operating in cluster. Models are automatically distributed to other cluster nodes, so we don't need to upload them on every cluster node. These models are shared by SNMP devices, so there is no need to upload it for every SNMP device. We need to upload only new models if the device requires them. Before we continue our demonstration, let's take a brief look at Postman and RESTconf. They were both already used during the models upload demonstration. RESTconf is the feature in ODL that is responsible for exposing data store through REST services, and the other one is Postman. Its REST client is used mainly for manual testing. Thanks to Postman, we can do REST requests manually and analyze their results or returned content. To be able to write data to data store, we first need to specify where we want it written. This information is part of URL, and then the data we want to write is supplied in the request body in the form of an XML or JSON structured format. The structure of data in request is based on the corresponding Yang model. The same goes for the part of URL that specifies the path to this data. Another important piece of information is that data store is composed of two parts. The first is configurational and the second is operational. In the configurational part, there are stored configurations for plugins or devices, and in the operational part, information about the device's operational state is stored. This is the same for SSB, so new devices with their configuration are added to the configurational data store, and their status or statistics are retrieved from the operational data store. That was a brief introduction to RESTconf, Postman, and data store. Let's continue with our demonstration. Now we are going to add our first SNMP device to topology SNMP. An SNMP device is added by writing its configuration as a node into topology SNMP. The important part of SNMP device configuration, besides the IP address, is also the set of models that the device is supposed to support. We need to specify this list of models in the device's configuration. If there is any error in the model's configuration, for example, the model is not present in the model store, then the device will be marked with an error status, and there will be no further interaction with this device from the SSB side until its configuration is corrected. There is a specific field in the device operational status that tells us about the error in configuration. Let's demonstrate this scenario with incorrect models configuration. The device configuration has been written. Now we are going to verify that the configuration is wrong by reading the device operational status from the operational data store. As you can see, the device has an error status, and we also have a brief description of the error. Now let's do this again with the correct configuration, and we can see that the device is trying to connect and we have no errors. And this is how we add a new SNMP device to the SNMP Southbound plugin. The device we are trying to connect to has a disabled interface, so as you can see the device is not connected yet. SSB tries to reconnect, and this will go on forever until the device is reachable again, or until we remove the device from topology SNMP, which means deleting the device node. We can also check if mount point is present. For this purpose, we have a support application, and we do this by calling the app's RPC through RESTconf. There is one particular RPC that reads all the nodes from topology SNMP and verifies if there is the corresponding mount point. As you can see, the mount point status for our node is unreachable, which means there is no registered mount point for this device in DOM mount point service. Now we are going to enable interface and wait until the status changes to connected, which means SSB was successfully connected to the SNMP device. We enable interface by the command no shutdown on the router. Now let's wait until the status changes. As you can see, the status changed to connected. Also, we can verify if the mount point was created by using support app. You can see the status changed to device, which means that the mount point is present and also that this cluster node manages the device, which means it communicates with it physically. Another feature that SNMP Southbound plugin provides is statistics collection. This feature is very limited and collects only a few selected types of data from the SNMP device. It is also required that the SNMP device implements MIBs containing data that are collected. To enable statistics collection, there are 3 switches in device configuration. If we set them to true, corresponding statistics will be collected. Statistics will be present in the operational data store according to connection status and other information. Let's add the node with statistics turned on. Now we can see collected statistics for this SNMP device. Before demonstrating reading from the device, let's take a better look at how reading from the device is done using RESTconf. In previous videos, we have talked about mount points and what is their purpose. They are used to access device content, which is a device's status, configuration, etc. We read or write this data using the DOM data broker service, which is one of the services provided by Mount Point. Also to receive traps in the form of notifications provided by DOM notification publish subscribe service. To access mount points through RESTconf, there is an extension that is added to the path in URL. We can logically split URL into 4 parts. The first is the address onto which the RESTconf is bound. The second is the path to the SNMP device node. Then there is the extension that tells RESTconf that we are accessing mount point. And after this is the last part, which is the path to data we want to read from the mount point's data broker. Let's demonstrate reading from an SNMP device. We are going to read iftable from our router. The path to iftable looks like this. How do we get this path? We got it, of course, from our translated Yang model. This is our model, and here the definition of iftable is located. Because iftable is the top-level container in the model, we write a path like this. The first part is the model's name, and the second, after the colon, is our iftable container. After running our REST request, we already have data contained in the SNMP device's iftable. Let's try it with other fields. That was the reading of SNMP device's content. We can also write to devices. It's practically the same as reading, but instead of a GET request, we use a PUT request. To demonstrate writing, we are going to change the system information of our router. First, let's check the actual system information. Now we are going to change the sys name, sys location, and sys contact field. Done. And now we need to verify if it was written. As you can now see, the device has new system information. That's all for the writing demonstration. Of course, we can have more than one device in our topology SNMP, so we are going to add a Linux SNMP agent. All we need to do is to write a new node with the right configuration, and it's done. Let's check the agent's status. The agent is connected, so we can read some information about our virtual machine on which it is running. For example, to see memory usage, all we need to do is read the right container specified in the Yang model that contains this kind of information. In our case, everything is provided by an agent based on the UCD SNMP MIB file, and this is our memory usage. Let's check some other information, like system information. As you can see, adding a new SNMP device and accessing its content is very simple. So that was all for device adding, reading, and writing. Next, we are going to test traps.